Hello, welcome to polyhedra. So a polyhedron is a closed spatial figure composed of polygons called the faces of the polyhedron. The intersections of the faces are the edges, and the vertices of the faces are called the vertices of the polyhedron. Now let's count the number we have in this polyhedron. Well, if I go to count the vertices, I have 1, 2, 3, 4. So I have 4 vertices in this polyhedron. Count the edges. 1, 2, 3, and then 4, 5, 6. 6 edges. And if I go to count the faces, those are 1, 2, the one in the back is 3, and the bottom one is 4. So I have 4 faces. So again, polyhedron is closed shape. Now we're going to look at special polyhedron, and those polyhedron are called platonic solids. Platonic solids are regular polyhedron that have regular polygons as faces. And be reminded that regular polygons are polygons with congruent sides and congruent interior angle measures, with the same number of faces meeting at each vertex. So here we have a tetrahedron, and a tetrahedron is named the number of faces, so it has 4 faces. Hexahedron, hexa is 6, so it is a 6-sided shape. Octahedron, octa means 8, so it's an 8-faced polyhedron. And then dodecahedron, dodeca means 12, so it is a 12-sided polyhedron. And icasa, I don't know if you know that one, but that's 20. So that means it is a 20-sided shape. And those 5 different polyhedron are called the platonic solids, because Plato proved that there could only be 5. So that's all there are. There are only 5 that are made up of regular polygons. Going on to nets. We've talked about nets. A net is a pattern that could be cut out and folded to cover a figure with no gaps. We made a net of a cube already in 6-1, and so now we're going to draw nets of different platonic solids. So the net of a tetrahedron, remember, is a 4-sided shape made up of regular triangles. And so I'm going to draw a triangle, a regular triangle that's equal sides and equal angle measures. And then I'm going to divide that into 4 congruent triangles. And that would be the tetrahedron. That would fold into a tetrahedron. The net of a hexahedron, again, a hexahedron is a cube. That's it. A hexahedron that will fold into a cube. So now you should have your polyhedron and the faces, the edges, and the vertice count, your platonic solids, Platonic solids, again, are named by the number of faces they have. A couple examples of a net. See how we could fold that tetrahedron right down into this net? And the hexahedron, which you know as a cube, we could make a net of that. Now there is more than one possibility that could be drawn for the hexahedron. What do you think about the tetrahedron? Can we draw that a different way? The next thing we'll be going on to is prisms, but that's for tomorrow. So going back to the polyhedron, here is an example of your worksheet tomorrow. We are going to go over polyhedrons, remembering that polyhedrons are geometric solids with polygons as faces. You will be asked to identify them. Also, we're going to go down and we are going to talk about the platonic solids. You should have them in your notes and go over the shape of each face, the vertices, the edges, the faces. And then we're going to look at a relationship that exists between the number of vertices, edges, and faces. This is known as Euler's formula. Do you remember Euler's diagram? That's a Venn diagram. That's also Euler's diagram. Euler is also known for discovering some things about polyhedron. And then below there are 5 nets, and you are to write the name of the platonic solid for each net. And then there's a fun activity on the back that computers. So make sure you have your notes. See you tomorrow.